Dear friends of water, thank you for this fascinating conference, for the organization, for the initiation of this conference, which is interdisciplinary. And as a forester, I would like to join, including Victor Schauberger, into our efforts to understand what happens with water. He was conscious that going into an academic or in a university formation, he would lose some possibilities of approach of nature, and decided not to go through the academic way. And that led him to incredible insights into water laws and water nature. And in this sense, I would also like to include my presentation, previous practitioners, people who worked with nature, who observed nature, and who discovered things which were not filtered by our modern academic way of thinking. And in this sense, it is possible to add one important factor into our work. It is the factor time in the cosmic astronomic dimension, but also in a smaller time dimension, which is very important. And in forestry, this factor is very important. We have, as professionals, another time scale. We think in generations, in many generations when we are making things, and that gives also, I think, to personality like Schauberger the possibility to have another view, another kind of focus. So at the center we will speak of cellulose and the relationship of cellulose with water. The trees are giants of time and space, and they are also the giants of the plant kingdom. And why have they this dimension? What is the fact, the chemical fact, who makes it possible? One of them, not the only one, was the addition to cellulose, which is the main component of the main structural component of aquatic plants, the addition of lignin. Lignin has made terrestrial plants possible with these structural possibilities, and has given resistance against decay to the plants, and gave them the possibility to attain an age of up to 5,000 years. The oldest trees have this age. So cellulose and lignin build a pair which is very important with other components, hemicellulose and so on. A first fact. And now water is an important element for the trees, naturally, for the photosynthesis, and the structure of the tree is made in form of tracheids for softwood trees. It's bigger vessels for hardwood trees. Here the example of softwoods. Tracheids is a system of capillaries, closed cells, and these cells are the ways where the water flow in the sapwood, outside part of the tree, into the crown, and flowing through these systems makes it possible to attain heights of up to 100 meters. And we had developed the theory of the upflow of this water in terms of cohesion. But using this word, it was in a previous time, and it was not aware that this water has another type of cohesion than just tap water like analyzed in laboratories. And that's a first very important addition to our understanding of trees, that the cohesion theory is much more a real fact than it was supposed before. And now, at the this way of going up into the tree needs cohesion because it's not under pressure, which would be linked to explosion, but it's under suction, under negative pressure, which is linked to implosion. Once again, we are here in phase with the views of Victor Schauberger. And now, this cohesive water goes through these capillaries. What is the chemical composition of these capillaries? Here, just a precise view. Here is a transverse section of such a tracheids, and the next one, the neighbor tracheids. And what's the composition of the cell wall? The cells are glued together with this lignin I mentioned before. We have here just a transverse section from a common part and the cell wall of the central cell. And that's this blue line. Where the cells come together, we have a very high lignin content as a glue between the cells. Hemicelluloses and cellulose are almost absent from this middle lamella and from the primary wall. And the secondary wall, which is the main part of the cell, is much more rich in cellulose, and the inner surface is still very rich in cellulose and very poor in lignin. But lignin is necessary for the solidity of the whole system, but inside the cell, it's cellulose. Cellulose being very hydrophilic, we have here exactly the conditions to make easy water as described in the works of Gerald Pollack and colleagues. So here we have an internal wall which is very rich in cellulose, and that's a very interesting observation. The trees could have made their water ducts absolutely like plastic, hydrophobe, because the trees know how to build waxes, for example, or other substances which are hydrophobic. And the cells could have been built as PVC elements in their properties. But it's interesting, it's not coated with wax, making the cells absolutely unpermeable. It's made of hydrophilic cellulose, a first fact. And now my reflection goes in the direction, what is now the link between cellulose and this flow of water? What has this as a consequence? Now, another aspect is this observation from the past, dealing with materials. The practitioners, the foresters, the farmers worked with the hands. They didn't have machines between themselves and the material, and were able to observe many things, and very precisely at the qualitative and also the quantitative level. And one fact which is widespread all over the world concerning forestry practice, but also agronomical practice, is a certain importance of the moon cycles, the moon phases, for the work with nature, for the properties and the qualities of the products. You can take any culture in the world which is still rooted in its place. Almost everywhere there has been a tradition of importance of astronomy in working with nature products. And now the oldest written testament or testimony of this knowledge is from Theophrastus, which lived a few centuries before Christus. And Theophrastus was the first to write about working with nature. And himself wasn't an experimentator. He wasn't a scientist. He was somebody who made interviews. He didn't discover that. He just noted what the farmers and what the foresters, what the people knew. And what is interesting with this writing, it is the most precise law or rule or writing about felling the trees, getting wood in certain qualities, and having a wood of the highest possible quality. And he expresses this rule in this sense that there is an appropriate season to cut the trees. Winter is different than summer, and in this season the wood will be harder and less exposed to decay. Two aspects which are linked together, which are linked to the cellulose lignin content and the interaction with water, if it is felt at the beginning of the decreasing moon. It is more precise than many actual moon calendars used by people making gardening. The first, the most precise, and that is what we have been able to verify scientifically using the standard methods. The moon, the main cycle is the change, the phases between new moon and full moon. We must make sub-sequences of 8 phases, in fact. It's not only the first quarter, the full moon, the third quarter. We must divide this phase much more precisely, and then it is possible to verify what Theophrastus has formulated from even more ancient knowledge. The moon rhythms are not only the moon around the Earth, the sun. That will be the cycle of the new moon to the next new moon. But before you have the moon placed in front of the constellations. So when the Earth is turning around the sun and the moon around the Earth, there will be a moment 2 days before where the moon will be placed exactly before the same constellation, that is the sidereal rhythm, a period which is shorter than the synodic period between full moon and the next full moon, or the new and next new moon. And then we have also a synodic rhythm, the tides every day. That are the 3 main rhythms which are working visibly on water systems, but also on the Earth system as a geological and flexible system. We have also tides and moon effects. And now the moon goes in front of constellations during 2 days in front of, in order to cross one constellation. And that is a very strange assertion coming from the past that say that where the moon is just passing has an importance for plants, for example. Is this possible? That is very far from conventional actual scientific representations, but we can take this as a hypothesis. And the forestry practice, everywhere. You can be in Amazon, in Korea. I had colleagues from there, or in Africa, where I lived also. There are practical uses, and which is interesting. For every use, you have specific dates which are favorable. Making chimneys in wood which won't burn, construction wood, firewood, it's not the same moments as to make construction wood, and so on. The resonance wood for violins need very special astronomical situations to have the highest properties in terms of acoustic properties for violin makers. And now we made research, I won't go very in detail here, on germination, on the buds of the trees are pulsating. during the whole winter. Then they open and they are pulsating according to the moon and specific planets, for example. The diameter of trees pulsates according to tides. You have electrical potentials in the trees which are pulsating every hour, every minute, day and night, and also according to lunar cycles and seasonal cycles, which are solar cycles. Fluctuation of wood properties, which was our core business for many years. And now I will just show a small thing, but very interesting about cellulose and water uptake. So, concerning the research, it is known how important the sowing date is for the result. Sowing 2 days before new moon compared to seeds put in earth 2 days before full moon. These 3 plants compared to these, that's the work of Lily Kolisko, who was at the initiation of the biodynamic farming system, where the time factor is a central one. Maize growth according to moon phases every day. Maize seeds in laboratory tests put in contact with water and growth and germination measurement. And that shows that every lunar week you have a peak and then a drop and again a peak and a drop and so on. In fact, the moon is not just a waxing moon and a waning moon. It's much more precise. If you look at that, you have lunar weeks with positive and negative modifications. That is our now element which gave us the idea to test this relationship between cellulose and water. Seeds of bean, for example, if you put them into water, you will observe, it has been made by Frank Brown in the 70s, 80s, seeds put into water every day at the same moment in the laboratory for 4 hours, taken out, how much water uptake. They didn't expect that, they discovered it by chance. It has a clear lunar periodicity. From every day is a dot, and from 1 day to 2 or 3 days later, you have changes of up to 20% less or more water uptake. And these seeds, when they are put into water, are at the same state. They are from the same pack or ground quantity, and they are dry. They are, in fact, inactive physiologically. And 20% cannot be explained only by internal changes of these bean seeds. For my comprehension, it has to do with changes in the water structural properties at that moment. And one moment will be able to take up much water, and then at another moment it will be more difficult to take up water. This research has been repeated with very clear verification. We made a big research with trees on the base of these old forestry rules. The wood has certain properties according to the moment when you cut the trees. And these researches had started in the 30s with quite few trees. And at the end of the 90s, there was really an interest for that, which began with our tests in germination of tree seeds in Africa. And then in this line, we started a very big research with the felling of more than 600 trees that was necessary to make a statistical correct methodology. We had to fell the trees at different places at the same time, and these trees were felled every Monday, every Friday in these 5 different places. At the same time, at 10 o'clock, the saw chains went on and cut 3 trees, and from them we got the samples to test in laboratory. Standard test according to norms, standard samples, And with these samples, we made tests on drying behavior. How fast is the water evaporated by wood? Because drying of wood is the first step of wood technology. You need to have constant water content in wood to make industrial transformation of wood. It has to lose the water, and it has been tested in laboratory conditions how fast or how slow is the water loss. Is this linked to the moon phases at the moment of the cutting of the tree? The results have been very clear. For spruce, chestnut, different, and in red, for example, dividing the moon cycle in 8 periods, we have many very clear differences around the full moon, which was before the number 4 and 5. Just before full moon, for example, water loss is high, and just after new moon, after full moon, the water loss is low. It has an effect on the density of the wood and on the shrinkage, the dimension change. I just make a summary of this. If you look at, it was made, this research, according to 48 felling dates during almost 6 months, simultaneously in these 5 places, and here is an example of one location. And here we see now what happens around full moon during the season. That was the start in October, the end in March, going through November, December, January, February. And before full moon, it is in yellow. And after full moon, just 2 days before and maybe 2 days after, it's in green. And the density is always changing from 93 to 105, and then it's again a change in this same direction, here again in this direction, and so on. And then the water loss was in the opposite sense, around full moon, before and after, before and after, before and after. And the changes are here about 10% for some dates in January, for example. And that can be shown like that, before full moon and after full moon for water loss here, these 4 months in a winter period. Just in February, the effect wasn't clear. That was standard representation, but it is told that these wood properties are remaining for a longer time, for generations. It's a definitive shape of wood, or a definitive modification of the wood properties if you fell the trees at that moment or at another moment. And that is a very intriguing fact, because the wood has to be dried. And after drying, we could expect that every water has been lost, and then everything is again put on at the level 0, and things are equal. But we will see that's not the case. If we make water sorption after drying, and this drying of wood was very, also according to norms, at 103 degrees in a drying oven, so-called oven dried. That means that every water which can be evaporated is evaporated, and it just remains water. There is still water in the wood above 103 degrees drying, but it's very tightly linked to the cell wall and not vaporable anymore. And with these dried samples, the long samples we have seen before have been tested in capillarity. They have been just immersed for 1/2 centimeter in water, all at the same moment. We know that the moment is important, it must be identical. And then it has been observed how much water is absorbed, and the weight increase compared to the dry weight gives us then the capillary absorption. And here, samples coming from trees 2 days before full moon compared to samples from trees 2 days after full moon in November, that was October, in December, January, February. We have here always in these 4 winter months drops in water absorption. And this other samples from the same trees have been immersed. And again, by immersion, it needs more time. Here it's 10 minutes, here it's 1 week immersion. We have the same drops. And what is interesting is the intensity of the difference, or the extent of the difference. Now we have before full moon and after full moon. The reabsorption of water compared to before the loss of water is much stronger. So the moon trace or the moon signal in the wood is very much stronger in terms of capillary ascension than for the water loss. Here we can have the propose that we have a kind of memory of material for its contact with water. When something happened, the felling of the tree, it's a moment where the bioelectrical potential of the trees has been disturbed. This is a signal which changes then the relationship between cellulose and water, and then through a drying process, going through a drying doesn't make it possible for wood to forget this moment, and the capillary, for example, ascension in wood, which is important for construction, can be very much lower according to the moon phase. Now, test cellulose and water as a specific relationship. Here we have the possibility from the cellulose industry to get very homogeneous material. This is almost pure cellulose, so-called cellulose pulp, used for paper or for chemistry. And cellulose pulp, these rolls are built in very short times. One sheet is made in a fraction of a second. It's an online industrial production. And in one sheet, you can get cellulose probes, which are very, very identical. There is almost no difference between neighbor samples from such a sheet, from such production. And then we immersed with a robotic system in our laboratory, constant conditions, temperature, humidity. A robot went to take our cellulose samples into a diapositive projector, which was organized to make a step every hour. And the cellulose samples had the dimension of diapositives, like here. And every hour, our robot went to take one sample and took the dry weight. We see that here. And then immersed the cellulose sample into water during 15 minutes, took it out, let the drops during a few seconds fall, and took a new weight in the wet sense, and then took it away and put away to the rest material. And the next hour, the next sample was taken. And this experiment has been made under constant conditions, every hour, night and day, changing water every day, one time for 24 hours at the same moment. And what has been observed? Things like that. That's during one day, that was the 25th January 2004. Changes like that, the impression that there are rhythms here. Is it a rhythm of 6.2 hours, which would be gravimetric or a rhythm from tides. The analysis using that's a fluctuation, for example, about through 3 times 44 hours, 3 days, 3 water replacements, but what is constant is these changes, and the differences are enormous, up to 7.7% differences in water uptake for constant conditions, same water, and absolutely identical cellulose. What happens? Where is the difference? I would say in water. Then we let spectral analysis be done on this material here, for example, for 25 days, the period 20 January to 13th of February 2004. And that was deceiving. And the colleague who made the spectral analysis had to say there is nothing. Here would have been 12.25 hours period corresponding to tides, nothing. And the colleague supposed everything is just white nose. So we could stop the research here, but it would have been disappointing. My reaction to this type of analysis, was it the right method? If you take, for example, cloud systems, rhythms in clouds, you could make the same analysis and nothing would appear because it's always with variability, but there is a rhythm. How can we find the rhythm? And if you take a too large scale, then these local rhythms will disappear. That is, I think, the problem for our series. But now we had to look, is it white noise, or is it a real change? So we had to make a single day and night series with multiple samples. And then, yes, I stop. Then the result was that the samples are clearly grouped with higher groups and lower groups. That was during the night. And box plots show that there is a significant change. So the cellulose is not just giving white nose. And then we had a question, what happens if we take the extreme samples, the samples from days where the absorption was high, compared to samples from hours where the absorption, it's not the same day, from hours where the absorption was low, putting these samples into the same water of the same moment a few hours later, gave us that. We had again a difference, significant. And in the same water, 24 hours later, without change, again this difference. So that was a first surprise. Again, something like memory. And the next was a verification. The next extreme samples, blue ones here, we had made the test with the first ones here. These are 2. And the green ones. And again, here, a clear difference. For me, there is something like a memory at the level of cellulose pulp in contact with water. What is impregnated in this cellulose which gives such behavior? I stop just giving an indication in what direction we could search. It's not my field, but Spherics by Hans Baumer. He explored the electromagnetic signals coming from weather fronts, from weather changes and air mass movements on water system, on cellulose systems, working also with the Fitzroy storm glass, which has been used by Admiral Fitzroy in the Beagle II expedition with Darwin. He was able to make prediction of weather in his boat, in this ship, just looking at the crystal formation of a closed glass vessel. Some days, that's my personal weatherfront tube. Some days you have something like that. Some days there is absolutely nothing crystalline, and other days you have crystals like that. Closed system in resonance with weather changes, and Fitzroy was able to predict and to organize his his travel with such devices. And Baumer has worked on this base and showed colloidal systems, and he was able to make measurements of these electromagnetic fields. There was a coherence with the crystal growth independently of temperature. So, thank you for your attention. I think taking this astronomical dimensioned time factor into account gives us the possibility to make a bridge between wisdoms from the past and science of the future. Thank you again for your attention.
Thank you so much, Ernst. And in the interest of time, I think we have time for one question only. Rumiana.
Thank you very much. Amazing. One comment and one question. We have done spectral measurements of 4 different waters over 4 years, every single day, following the moon. And I can tell you that we could find the same differences. And your work is a beautiful proof of easy zone being maybe bringing the memory. Because when you evaporate water, what is left is the easy water. And we could see the easy water in the spectrum. And this is what actually is bringing the information and carrying the information. Now my question is, when you have you done this experiment for different years? For example, if you compare December, January, February, March let's say, okay, January, February, March of 1 year, and then January, February, March of another year, you might get some differences. What do you think?
That would be interesting. It's a very simple device. We made that with our students, and now I'm not in the position anymore to repeat the same experiment, but the methodology is quite simple. And it could be done with a simple balance. It must just be precise enough, but you don't need robots, but you need people making the measurements. So I think it's interesting also from this point of view, science can be very simple. With a new question, you can start with very simple devices and bringing pupils, young students to science, to real science with very simple methodologies. We don't need to be very complicated to discover new things. And I think that's one aspect of these researches. So thank you for your remark. I think making especially wood analysis with these methods will bring us much more further. Thank you.